Okay everyone, today we will start dividing fractions. So we'll do this over 2 days. Just like with multiplying, we'll save the mixed fractions for next day. So yeah, you're right. I'm going to start by doing some pictures here. So the first thing I have is 1/2 divided by 3. And I've put a hole here. And what I'm going to do is I'm going to represent 1/2. So what would I do? I'd break it into 2 equal pieces. I'm sorry if it's not perfect. And I would shade in 1/2 of it. So this yellow bit right here is 1/2. And then what I want to do is I want to divide that 1/2 into 3 pieces. I want to break it into 3 equal pieces. I shouldn't have used a circle. It makes it kind of hard. But if I divide that into 3 pieces, what? I'd have one around there and one around there. And so the question is, what size pieces are these now? Each one of these shaded ones, like let's just shade one of them. What size is this piece right here? Now, we're not talking about what size is it of the shaded. It's 1/3 of the shaded. We're actually talking about the whole. So I need to actually extend these, don't I? So I can see that these pieces, the shaded one, the purple one, the 2 yellow ones, all these pieces are sixths. And so this purple one right here, which is my answer, is 1/6. This is 1/6. Okay, let's try another one. Here's 3 and we're going to divide into half. Now again, remember from an earlier video I said there's 2 ways to think of division. One is split it into 3 groups. That's what we did in this one. The other thing is how many of these can you get into there? How many go into it? So how many halves go into 3? Oh, okay, well that's easy to figure out. How many halves go into 3? Here's my 3 holes, and I have 1/2 here, a 2nd half here, a 3rd half here, a 4th half here, a 5th half here, and a 6th half there. So my answer is 6. There's 6 halves that make up 3. All right, and then we have this 2/3 divided by 1/6. Ooh, this is a tricky one. So what you could do is start by splitting this into thirds. So something like that, and shading 2 of them to make 2/3. And now we're going to divide by 1/6. So you could do it either way you want. You could either split the shaded part into 1/6, or I think of the way I'll do it is I'll see how many 1/6 go into 2/3. So what I should do is make sixths here. Make my circle split into sixths. So let's see. If I put a line here, a line here, and a line here, I've now split this hole into 6. How many sixths are shaded? 1, 2, 3, 4. So my answer in this case would be 4. All right, I don't know if it really helps, but I do, I think it's cool to draw the pictures, and maybe it'll give you a little bit of a sense of what we're talking about when we're dividing by fractions and stuff. But probably you're never going to use that. Probably what you're going to use are the rules that I'm going to give you right now. So let's go through the rules. First rule, you do not need a common denominator. Just like with multiplication, do not get a common denominator. You can, but you're just making the question more difficult. It's unnecessary. Number 2, don't actually divide. Don't do it. What you're going to do instead is you're going to multiply by the reciprocal. Whoa, what does that mean? Well, we better take a time out here and go down here where it says reciprocal. What are we talking about when we talk about the reciprocal? We're talking about the resulting number when a fraction or number is inverted, or when it's flipped. So it's a pretty simple concept actually. If we want to know the reciprocal of 4/5, you just flip the 2 numbers. The 4 comes to the bottom, the 5 goes to the top. The reciprocal of 4/5 is 5/4. How about the reciprocal of 9/8? Flip the numbers around, 8/9. How about the reciprocal of 7? What? How do we do that? Well, it would sure be easier if this was a fraction. Can we make it a fraction? Sure. 7's the same as 7/1. Now if we do the reciprocal, flip the 1 to the top and the 7 to the bottom. Okay, the reciprocal of 1. Well again, let's make it a fraction. So it'd be 1/1. So what happens? 1 goes to the top, 1 goes to the bottom. Hey, you get 1/1 again. And 1/1 is just the same as 1. So in other words, the reciprocal of 1 is 1. It's the only number where the reciprocal of it is exactly the same. Actually, it's not true. There's one other number that it's the same. See if you can figure that out. Tell me in class, give you candy there. All right, the reciprocal of 1/8. Well, the 8 comes to the top, the 1 goes to the bottom. But wait a minute, 8 over 1, why don't we just say 8? And the reciprocal of 4 and 2/3. Don't do this. Oh, I guess the reciprocal is 4 and 3 over 2. No, wrong. Any guesses what you have to do first before you can get the reciprocal? You have to start by putting it into improper form. So 4 times 3 is 12, plus 2 is 14, and keep the denominator the same. Now we can get the reciprocal. 3 comes to the top, 14 goes to the bottom. Okay? So when we divide, we're actually not going to divide. We're going to multiply by the reciprocal. So again, I got one more thing to say here, but let's just go ahead and show you what I'm talking about. So what I do when I want to divide is, with the first fraction, do nothing. Keep the same. Keep the same. So if it says 2/3, it's still going to be 2/3. However, we don't want to divide, so we're going to switch that division sign. We're going to switch to multiplication. So it's now 2/3 times, but you can only do that if you change to the reciprocal. So what's the reciprocal of 5 over 7? If you flip it, the 7 comes to the top, the 5 goes to the bottom, you get 7 over 5. Hey, guess what we got now? We got a multiplication question. So now you just have to remember the rules for multiplication. So remember, you're going to multiply across the top. 2 times 7 is 14. You're going to multiply across the bottom. 3 times 5 is 15. And you're done. Now, what's one other thing you could have done with multiplication? You couldn't do it in this case, but you can sometimes do. Ninja slicing. So that's my last point for you here. The last point is you can't ninja slice until after you turn it into a multiplication question. So basically with a division question, yes, you can ninja slice, but not until you turn it into a multiplication question. So if you were doing something like 4 over 7 divided by 3 over 8, you could not ninja slice the 4 and the 8. You can only ninja slice when it's a multiplication question. So not until you flip it can you then look to see if you can ninja slice. All right, let's try this question. So I'm going to rewrite all of them. I really think it is a smarter way to do it rather than trying to do it in your head. Some people have methods where they multiply this and then multiply this and put one over the other. I mean, you do you as long as you're getting them all right. But I'm going to rewrite them all. So I'm going to keep the first fraction the same. I'm going to change my division to a multiplication. I'm going to do the reciprocal of 8 over 9. I'm going to flip it and get 9 over 8. Great, now it's a multiplication question. I can look for ninja slicing. Can I do any ninja slicing? Yeah, I can, the 4 and the 8. Divide them both by 4 and I get 1 here, and 8 divided by 4 is 2 on the bottom. And now I can multiply. Right across the top, 1 times 9 is 9. Right across the bottom, 5 times 2 is 10. Finished. Okay, next one. 5 over 6, keep the first one the same. Don't want to divide, we want to multiply. And then we flip the second one, reciprocal, 18 over 5. Okay, we'll look to see if there's ninja slicing. Definitely a lot of ninja slicing. We got the 5 and the 5. Divide them both by 5, you get 1 and 1. And the 6 and the 18, divide them both by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. We've got yet another case, we're getting 1 on the bottom. 1 times 3 is 3. 1 times 1 on the bottom is 1, and if you've got 3 over 1, we're just going to say 3. Okay, next one, 9 divided by 6 over 11. Ooh, isn't it nice when we have fractions? Let's make it a fraction. Let's make it 9 over 1. So that, I didn't change anything. 9 is the same as 9 over 1, right? They're completely equal to each other. I don't want to divide, I want to multiply, and then I flip the second fraction. So instead of 6 over 11, 11 over 6. Ninja slice? Yes, the 9 and 6 can both be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Now we're good to go. 3 times 11 on top is 33. And 1 times 2 on the bottom is 2. That's fine with me. You can leave that answer. Or, how many times does 2 go into 33? Ooh, it's not the easiest thing in the world. But it goes in 16 times. That gets you up to 32. So you have one more to get up to 33. Denominator stays the same. Either answer is great. Okay. This question, 5 over 8 divided by 20. Well, remember, this is 20 over 1. You better remember that first before you do any flipping or anything. Okay, let's write the new question. Keep the first fraction the same, 5 over 8. Change it to multiplication, and now flip this. So it should become 1 over 20. The reciprocal of 20 is 1 over 20. Now we can ninja slice. So our 5 and our 20, divide them both by 5, you get 1 and 4. So across the top, 1 times 1 is 1, and across the bottom, 8 times 4 is 32. Finished. Either one here. Alright, doesn't this look awful? What is this? This is called a compound fraction. You've got more than one fraction in a fraction. The important thing to remember is this line right here means what? It means divide. Anytime you see like a fraction line, it means divide. So the one right in the middle means divide. I could rewrite this as 4/5, keep it as a fraction, but instead of writing that line, that red line right there, I could write divided by 8/10. Alright, these are exactly equivalent to each other. Well, once I figure that out, the rest isn't too bad. Just do the same thing we've been doing. Keep the first fraction the same, change the division to multiplication, and reciprocal of the second fraction. Flip it. 10/8. Ninja slicing? Yep, I got a 4 and an 8. Can divide them both by 4, so you get 1 and 2. And I got a 5 and a 10. Divide them both by 5, you get 1 and 2. And then I have a 2 and a 2. Divide them both by 2, I get 1 and 1. So what do I have? I have 1 times 1 equals 1 on the top, and 1 times 1 equals 1 on the bottom. Well, 1 over 1 is just the same as 1. That's the answer. Alright, one more problem. Stu has 6 chocolate bars. He would like to give everyone 1/3 of a bar. How many people can he give chocolate to? Okay, imagine he had 6 chocolate bars and he wanted to give everyone 2 chocolate bars, 2 bars. How many people could he give it to? Well, you do 6 divided by 2 equals 3. He could give it to 3 people. Well, it's the same sort of thing here, except you're not going to go 6 divided by 2. You're going to go 6 divided by 1/3. We want to know how many 1/3s go into 6. Alright, well, how are we going to do this? Let's make this a fraction, so 6/1. We keep the first number the same, it's 6/1. Change the division to multiplication, and flip the second one, 3/1. Any ninja slicing? How about the 6 and the 3? Can we do that? No. Remember, you have to have one in the numerator, one in the denominator. In other words, one on top, one on the bottom. There's no ninja slicing you can do. So you're just going to go ahead and multiply now. 6 times 3 is 18, and 1 times 1 on the bottom equals 1. Oh, well, 18/1 means 18. 18 people could get a piece of chocolate from him. Makes sense, right? Another way we could think of this is, in every bar, he can feed 3 people. If you have 6 bars, then that 6 times 3 equals 18 people are getting bars. And if you look, that's basically what you did do. You see this 6 times 3 right here? Well, look what shows up right there, 6 times 3. So really, with division, you're definitely just change it into a multiplication question. Alright, I hope that makes sense. Next day will be pretty straightforward if you understand this, because we'll be doing more division with mixed numbers. And I bet if you think back to multiplication of mixed numbers, I bet you can guess what that'll mean. Take care. Bye.